Hi, everyone. Thanks for joining us. We're going to give people a few minutes here to join, and we'll get started in just a couple of minutes. Okay, I think we're going to go ahead and get started, and I'll keep admitting people as they join. Um, we will have a Q&A opportunity at the end of this, and you can add your questions to the chat. So I think with that, Jared's going to start us off and enjoy the webinar.
Thanks, Jessica. Can you hear me and see me okay?
Yeah, looks great.
Great, great. Hello, everyone. Thank you for joining the Fluence webinar today on unlocking the power of high purity water treatment. Um, my name is Jared Galligan. I'm the Director of Engineering for Fluence in the Industrial Water Group. And have roughly 20 years of industrial water treatment experience, both in the equipment manufacturing side as well as the chemical treatment and manufacturing side of water treatment. So I'll be one of the presenters today. And I am located at our global headquarters in Minneapolis, Minnesota, in the US. Wissam?
Yeah, this is Wissam Al-Ghost, General Manager of Fluence Middle East. I'm in the region for more than 25 years and in the market of water and desalination and high purity for the last 22 years of my career. I'm located in Dubai, and we are handling the regional services for Fluence Middle East and the Gulf, Middle East, North Africa, and Southeast Asia.
Thanks. So I just want to share a couple brief slides about Fluence, since many may not be familiar with our organization or our offerings. I'll keep it to just a few moments here before we get into the technical topics. So Fluence's vision is to become a leading global provider of fast to deploy, decentralized packaged water and wastewater solutions. Or in other words, we're looking to provide water and wastewater treatment systems at your given facility or at the specific point of use. And we do that in a very quick model and pre-engineered model. And I'll show a few examples of that in a moment. We are a global company with projects all over the world. I sit at our global headquarters in the US. As Wissam said, he's in our regional office in Dubai. But everywhere you see a square here is a Fluence office, an engineering office, sales office, manufacturing, research and development, and different technical centers of excellence. So we can pull from various resources around the globe to support a project that can be just about anywhere. Wissam and I largely focus on the industrial market, and that comprises both water and wastewater treatment with traditional technologies like sand filters and ultrafiltration and RO. But then we have a whole other side of our business focused on wastewater side that is primarily biologically driven. Anaerobic systems, aerobic systems, MBR, MABR, and a host of other technologies to support those industries. Looking at it a little bit different way, again, Wissam and I largely are in the water treatment and wastewater treatment segment, but we often combine and overlap into other areas like waste to energy, and our fastest growing segment is water reuse. Being a global company, we have a long customer list of both very small organizations to very large organizations. I won't read them all off here, but you can take a quick look and recognize that we work with some major market players.
In the region, we have some good relation and projects working with Suwaidi, Technical Surveillance, Emirates Global Aluminium, and treated sewage effluent, working with حسن علام, إيجات, and هيئة المحتميات العمرانية, نوكا.
Thank you. Going a different direction here, digging one step deeper into Fluence's industrial water treatment equipment offering. Most of our equipment centers around membrane-based treatment systems, things like ultrafiltration, nanofiltration, reverse osmosis. But then we extend further into deionization to produce pure water or high purity water, as we'll get to talk about in a moment. And we combine those technologies for reuse treatment systems and some specialty applications like lithium brine treatment and a host of others. And all throughout, we provide ongoing support in the form of aftermarket sales and service, spare parts, consumables, remote monitoring, and many other offerings.
And also we supply solution. We are a solution provider. If there is any problem in water, we don't stick to such technologies only. We look onto the water, and we design a custom-made solution that fits the requirement to treat such water.
Great. When we look at markets that Fluence most commonly operates in, food and beverage is our largest market, but right behind it is the power industry, both traditional natural gas, coal, diesel fuel oil, and biomass. And then we extend in other areas like manufacturing, desalination, and some other specialty applications too, like lithium mining treatment. Just share a couple pictures here of some recent projects, big and small, from RO systems that have all polished stainless sanitary tubing to some complex ultrafiltration systems. To just kind of give you a very quick snapshot of the type of equipment that Fluence produces in the industrial water market. I do want to mention one of our specific products before moving on to high purity water, and that is our NiroBox offering. These may look like a 40-foot ISO shipping container, and for all intents and purposes they are, but these are actually designed from the ground up to be modular treatment systems of water for water treatment. They come completely factory wired, piped, tested, so they can be installed and commissioned in a matter of hours to days, and a water treatment plant can be up and running. We can often combine several of these. Go ahead.
We can supply multiples of this in order to fit the water requirement.
Exactly, as in this plant here, we have multiple units operating together to increase the flow, or sometimes we can have one system or one container include only one technology like RO, or a second container could be provided to provide a polishing step like a DI system.
In addition to this, to the Nero box, we have it is a full package, plug and play, UFRO, or it can be a multimedia filter but plus an RO.
Great. Thanks, Wissam. Okay, so getting into kind of the meat of today's presentation is high purity water. The title was Unlocking the Power of High Purity Water. And getting into that, first we kind of have to define what high purity water is. And we can look up a dictionary definition for something like demineralized, deionized, ultra pure water and get maybe a single description of that. But what Wissam and I see in industry is these terms are so often interchanged, and what industry might ask for demineralized water might be very different. For example, we just recently were requested to provide a proposal for a water treatment system for a beverage manufacturer looking for a pure water treatment system. And when we look at the specific quality of what pure water was to that beverage user, it wasn't that much different than the city water that was coming into their plant today. Whereas speaking to a semiconductor chip manufacturer like Intel or Samsung or the sort, a pure water or an ultra pure water to them means something that has contaminants on the level of nanograms per liter or parts per trillion if you're using US units. And so it's very important. Yes, we see these terms often, but what really matters is when we get down to the specific water quality, the conductivity, the parts per million, the nanograms per liter, micrograms, whatever that might be, that's going to determine the treatment system that's needed.
Yeah, there is a lot of challenges for such water, and as much as complicated it will be, then the sophisticated the system will be. But there is the know-how and the experience and lesson learned that was gained through a multiple of projects that was executed by Fluence, which is always implemented in the new projects to get the more efficient and uh, custom solution that is required and that meet the requirement of the client.
Great. So what I want to focus on just for the next few slides here, just a high level overview of maybe the most common treatment technologies that make up a water treatment system, whether that's a high purity, demineralized, deionized, whatever that might be. There's often common technologies that you see throughout. These few slides are not meant to be a very technical explanation or detailed discussion on these technologies, the pros and the cons and costs, but rather just a very high level overview of the technology and where it's often used. If you would like a detailed technical training on these given technologies, Wissam and I, please send a note and we can connect you either with our own materials or with several manufacturers of these given components. Will have a detailed training event describing all of the pros and cons on these technologies. With that said, one of the most common pre-treatment steps we see in a water treatment system is some sort of filtration system. I'd say most common today is ultrafiltration, which can be used interchangeably with microfiltration. There's some minor differences between the two, but generally the technology, the core of it is the same. And ultrafiltration is a membrane that is used to remove suspended materials, turbidity, suspended iron, in that raw water supply. It has excellent removal of those contaminants along with pathogens. Has no impact to dissolved solids. Hardness, chloride, silica are unchanged through an ultrafiltration system. Its common application is, at least in the US, becoming more prevalent in potable water treatment for drinking water. But on the industrial side, it's most often a pre-treatment technology to a further technology we'll talk about here in a moment. Next technology, as we move to higher levels of filtration or a higher degree of treatment, is nanofiltration. And this one isn't as common. There's some reasons for that we can discuss offline if you would like, but it uses a membrane, a polyamide thin film membrane, to remove dissolved ions from water. It's also very good at removing color. If you are familiar with RO technology, just in general, membranes, pumps, filters, fluxes, that's sort of general knowledge, almost interchangeable with nanofiltration. There's some differences such as feed pressure and recovery rates and the like, but largely the technologies are the same. Notably, though, with nanofiltration, does very good removal of divalent ions, things like calcium, alkalinity, sulfate, but it does not remove ions like sodium, chloride, and some others very well. It removes partially, but not very well. It's a unique technology that's needs to be applied correctly, but we do see some applications where it makes sense as part of a high purity water treatment system.
Nanofiltration, lately they were using it in brine mining RO systems, and it was one of the technologies that was considered as a pre-treatment for the RO system.
Reverse osmosis, definitely I would say the workhorse or the most common technology used in a high purity water treatment system. Again, it's membrane based. It removes dissolved solids very, very well. But it's susceptible to fouling and scaling and some other issues that need to be addressed with proper pretreatment, and we can certainly help with that. But there are limits to how well or how much dissolved solids or dissolved minerals an RO system can remove. Generally, it removes about 98, 99% of the dissolved solids. If we need higher purity, we can often add another RO after it, or a polishing RO, or the term the industry uses is called a two-pass RO, that can remove another high percentage of remaining minerals. But we reach a point where we can add an RO after an RO after an RO after an RO, and the finished water quality will no longer improve. There's just a maximum removal in terms of parts per million or milligrams per liter that RO technology can create. Generally, when the water quality is required by the treatment system is less than 1 milligram per liter, we need an additional polishing treatment step after this. I know that's a lot of information. Again, we'd be happy to discuss after more technically on RO technology.
Yeah, to add different RO in series, it means that you are also consuming a lot of power. So this will not be efficient. So that's why we are limiting only on, mainly the common practice is to go, if you are going for a less than 1 milligram, you go for first pass and second pass RO only, and then you go to a polishing, as Jared said.
That's a great point, Wissam. Yeah, in areas where energy is very expensive or hard to get, that's a great consideration. The next technology after we have RO permeate or a relatively clean water, the technology most often used is electrodeionization, EDI, or in some instances we have the letter C meaning continuous electrodeionization, but they're used interchangeably. And EDI is a resin-based technology. Inside those white housings there, those modules are a mixture of cation and anion resins. If you're familiar with old demin water plants or separate bed demin plants, same resins, only rather than regenerated with chemical, we regenerate them continuously using electricity. And so we don't need strong acids and strong caustic and neutralization or all the safety concerns with it. EDI is very effective at reducing water quality that has maybe single digit milligrams per liter to very low levels of micrograms per liter or parts per billion in the treated water. It does have some concerns with scaling and in some instances fouling that we need to address with good pre-treatment. but largely it's an excellent technology at producing, I'll say, approaching high purity water or demineralized water.
I can add on this on for continuous electrical deionization is a good technology that, as you mentioned, regarding the use of chemicals, and acid and caustic are very hazardous chemical. So for certain refineries or power plants to have such chemicals on site, it will cost them in the insurance. So the value of the insurance will be high. So nowadays we are seeing that most of the power plant are shifting from the resin base or ion exchange into electron deionization because to reduce the insurance cost.
That's a very good point, Wissam. You reminded me, I've been part of several projects specifically in Latin America and South America where a plant had an existing acid caustic based ion exchange system, and they replaced it with EDI just from insurance and just from a safety standpoint. No one would like to have acid and caustic in their plant if they can help it.
Yeah.
Lastly, in certain instances, specifically when we start reaching what I call ultra pure water or water that's used by maybe semiconductor manufacturers or some very high pressure steam systems that parts per billion or micrograms per liter is not clean enough. We need even better removal. We don't really have another choice other than an ion exchange based or resin based treatment system. Oftentimes we hear the term mixed bed DI or mixed bed ion exchange system. What that implies is a vessel like in that picture there that has a mixture of cation and anion resins that can remove the last trace amounts of dissolved solids. And oftentimes in some industries like semiconductor, we might add several of these in series to really reach very, very low levels of dissolved solids. So again, most common, I'd say, in semiconductor industry, where we see those. Wissam, on your side, maybe in your area of the globe, do you see much of this beyond semiconductor anymore?
Yeah, previously, yes, we see. I have been installing several of these units, but it is not an easy to operate. There is a lot of control, a lot of valves, sophisticated. Sometimes you need to remove the resin outside and then bring it in, regenerate it in a different vessel. So there is a different systems, and the resin you need to change it. Sometimes you need to have a cation and then a degasser, then an anion after, and followed by a mixed bed ion exchange. So it's taking a lot of space. Plus, it's not a user or operator friendly. While for the CEDI, you have a one skid that it solves all your problem with the RO, with the help of the RO, because sometimes you need to reduce as we mentioned, we need to reduce the salinity before to reach the EDI so that it can accept. There is some limitation on the EDI to accept such water.
Great, thanks. We kind of covered again the high-level treatment technologies, ultrafiltration, microfiltration, nanofiltration, RO, EDI, ion exchange, mixed bed. So where do those technologies or which of those technologies are commonly used in which applications? And so I just have a couple slides here that are broken down by industry, food and beverage, and semiconductor on these slides. And I won't read these verbatim, but you can see that where those previous technologies I described are often used in these plants. In food and beverage, things like process makeup water systems or ingredient waters very often use UF and RO. Whereas utility water systems, both in food and beverage and semiconductor, benefit from using RO water to their boilers, RO water to their cooling towers in some cases. And then often these plants can also have extensive wastewater treatment. It might include biological, or it might include just chemical, physical treatment, or sometimes both. And so you'll see these technologies used throughout. In the automotive space, Fluence does have some experience here and a growing list of projects, specifically in the electrical vehicle market, as well as general manufacturing of car parts where they might paint the body component or coat it, and they often rinse it before and after with a high purity water. And those applications do require very clean water. We often see RO all the way to EDI and ion exchange so that that final rinse water does not leave any staining or spotting on their car parts. A much smaller application is the healthcare industry, often uses steam to sterilize surgical instruments. And the cleaner that steam is, the better the cleaning process is. And to make that steam clean, we often use technologies like RO to do so. Lastly, one of our largest markets, certainly with SOMs as well, both in North and South America and growing in the Middle East, is the power industry. In the US, it's very hard to walk into a power plant that's built in the last 10 years that doesn't have an RO system in it, a DMIN system, ion exchange, because those gas turbine systems, the steam turbine systems, their tolerances for impurities in the water become so low that we need very good levels of treatment in those systems. Wissam, anything to add? Would you say that's generally the trend as well in your part?
This is the trend also here in the region, in the Middle East and the Gulf. We have received a lot of RFQs asking for a seawater RO followed by a second pass RO followed by an EDI. So we in the last 10 years, EDI was not the familiar in the region, and they were always asking when we were bringing to them an EDI, it is something strange for them. But now, and they prefer to have the ion exchange mixed bed and cation. But nowadays, the trend in the region is either a UF RO and EDI or multimedia filter UF RO EDI. It depends on the water quality. And most of the power plant and the existing power plant or the old power plant are shifted from open cycle into combined cycle. And to go for a combined cycle, they need to have an ultra pure water. And this is where we have to supply maybe a second pass RO, because maybe they have if it is a very old plant, they might have a thermal desalination, or maybe they might have a only seawater RO for the cooling tower. But nowadays we are adding a polishing RO as a second pass RO followed by an EDI. It happens several cases in the region. So it is the RFQs or the projects is increasing in the region on seawater RO, second pass, and EDI.
Thanks. So we kind of covered the maybe market applications. Now I just want to touch on a few case studies, both from I want to touch on some case studies of past Fluence projects that included a high purity or ultra pure water treatment system in a wide variety of industries. I'll touch on a few, and then Wissam can present several as well. This was a gas-fired power plant, or I believe this one was a combined cycle that needed demineralized water, or what they call demineralized water, water that the finished conductivity was less than 0.1 microsiemens per centimeter, or if we change scales to resistivity, oftentimes we're talking 10 mega ohm resistivity. When we often go to demineralized water, we start talking in terms of resistivity rather than conductivity. This particular project included a treatment process that Wissam often just described. This one used ultrafiltration of seawater followed by a seawater reverse osmosis, and then a polishing brackish water reverse osmosis before final polishing via EDI technology. This particular plant created about 700,000 gallons per day. It was a number of years ago, as you can see, but it's still functioning today using these same treatment technologies. Second power plant is a biomass power plant. Usually these require much smaller volumes, both of demineralized water and cooling water, and you can see that is the case here. This was a skid-mounted system that used where the plant was fed raw well water, both was fed raw well water to create demineralized water, again using UF, RO, and EDI technologies. Much smaller at less than 100,000 gallons per day. This one was done several years ago, but is still running today.
Yeah, as long you are operating it properly and the pre-treatment is good, designed properly, then the lifetime of the plant will increase. Usually in when we design such system, there is a lifespan, and mostly the lifespan is linked to the RO membranes or the EDI membrane. But if you have a proper pre-treatment, you have proper operation and maintenance team trained, then the lifetime can be increased. I have been involved in project. We are talking about 40,000 cubic meter per day, and the RO membrane lasted 9 years, just because there was a proper pre-treatment. And it was the media that was selected because it is an MMF. It was selected to have a high porosity so that we reduce the turbidity as much as possible. So I believe that to increase the life span of the plant, you need to have a proper designer, and I think Fluence is your partner for that.
This particular project was in the South America region, and while it was not producing what I would consider a high purity water, it was creating a high quality water. It was a facility that drew ocean seawater and used UF technology and RO technology, and then UV disinfection, and then finally a remineralization system to produce potable water or drinking water for a city. Again, this one was several years old, but you can see both by the pictures and the flow rate, this was a pretty large project. And so I put this up here because it was producing what some industries would consider a high purity water, whereas other industries may not consider it high purity enough. But we can help certainly with potable water treatment projects as well as industrial treatment projects as well. Next project I'll share before handing it over to Wissam to present a few of these. This was a combined cycle power plant also in South America that was part, I'll call it raw water treatment, but also part reuse water. They were in an area where they could not receive as much raw water as they would like for the plant, and so we had to get creative in the treatment design. And so we had a well water treatment system, and we had a cooling tower blowdown treatment system that allowed the reuse of that water. We used UF for the cooling tower and media filters for the well water, but then we combined those streams together and used RO, polishing RO, and EDI to create demineralized water for the plant. This one again was just a few years ago that this was commissioned. I enjoy this picture because you can see on the right there, this one required a two-story or two RO systems, one on top of the other because of available space was very low. And that's a type of design and feature that Fluence can incorporate into our systems if needed. But Wissam, if you wouldn't mind taking over and presenting these last few.
Yeah, this is a project that to produce, we have used 15 Nero boxes of 480 meter cube per day, and this is for a power plant. in the Middle East region. The technology was using pre-treatment like multimedia filter activated carbon. We have cartridge filter two-pass brackish water, RO, and then we have a gas transfer membrane, which is this is for to degas the CO2 from the water before entering the CEDI. This technology has helped in reducing the NOx emission, and such system is required for not only in power plant. It's also required in waste to energy projects where you need to as Jared mentioned, sometimes you need to have cooling water without any contamination. It has to be less. The conductivity must be, as mentioned, 0.1, sometimes 0.01 microsiemens. So this is the challenge here was we have the client, he need more UPW, ultra pure water for his generators, and accommodating this has increased in a gas transfer. So we have to use CEDI system. Next slide. This is a project that it is ongoing now in Saudi Arabia. Our client, they are building a new power plant, and they have a limited space, and they have a limited time also. And for cost effective, we have offered them Nero boxes, four Nero boxes as a seawater, with another three units as a second pass brackish water, plus three trains of EDI. The plant will be custom made as per the plant design shown in the picture below. The RO skid we have combined, the EDI skid we have combined the three trains in one skid in order to save place. So we can custom made even the Nero box, which is our standard design. We can custom made it in order to fit to the client requirement. And you can see we have around 8 containers plus multimedia filters as a requirement. So we are using here multimedia filters followed by an ultrafiltration per Nero box, followed by a brackish water RO, and then in EDI. We are producing here 3 types of water. We are producing cooling water, service water, and we are producing potable water. So we have 3 different types of water going out from the plant as per the requirement and as per the capacity required. And this and such modulating system can be expanded easily and can be operated easily from a control room or from a SCADA system that combine the complete containers into one SCADA. And in addition to that, the proposal from Fluence was even the client, they want to remove one of the containers of the Nero boxes and relocate it. It can work also as a standalone. So it is either you can run it in total or combined, or you can run it independently.
Great.
Next slide. I think, Jared, this is for you.
Oh, yes, yes. So this was a previous project with a relatively quick time frame, also for a power plant. This one happens to be all the way in Australia, for a remote site, a very remote area for a power plant. Only around 1,000 cubic meters per day, because again, these power plants, newer ones, generally do not need a high volume of demineralized water. It included pre-filtration through media filters, and then ultrafiltration for suspended solids removal, a 2-pass RO, a gas transfer membrane technology, and then final polishing via continuous electrodeionization. You can see from the picture there in the lower right, kind of those white boxes, those are also Niro boxes or a containerized plant. Allows for very quick site installation. You can see there's no building was needed. The interconnecting piping and wiring is very minimum for this type of arrangement. So a really nice project. Similarly, maybe not reaching right to the level of high purity water, but this project included both ultrafiltration and RO technology for around 1 million gallons a day of produced water treatment, in which the final water was used for irrigation. Again, a completely containerized, compact solution there was shown.
The good thing in our Nero boxes are we reduce the waste, so we have a high efficient and we use every drop of water. Even the reject, we use the reject water to backwash our ultrafiltration. So it is a patented technology for Fluence, and this by using this technology, or by using this, it's not a technology, it's just a brainstorming or a solution that we use where there is a lot we want to use, or there is scarcity on the water, so we want to use as much as possible the water that is coming in and or rejected, in order to increase the efficiency of the Nero box.
That's right.
This is one of the first projects that I have done in electrodeionization in the region. It was the first project I sold, actually, and I was part of the design and engineering. This is a CEDI skid. It's producing 66 cubic meter per hour. I think the MGD is wrong. I think it needs to be corrected. The ultra pure water, there is in the same site, there is 5 ion exchange mixed bed, and this is the only EDI installed there. Now, after several years of operation, we are now refurbishing it. Fluence was awarded the project to refurbish the existing plant. We are changing and modifying, because there was some we can say operating errors from our client, and then we are changing all the EDI modules with the new ones, because of the resin is exhausted after I think 12, we are talking about 15 years of operation. So this is one of the biggest aluminum smelters in the world that is using such EDI. We are providing skid-mounted EDI unit and using RO permeate from desalination seawater RO and second pass, and the water is produced for cooling in the combined cycle power generation. While we are talking about projects in the region, we have to mention our biggest reference, which is phase 1 of New Mansoura in Egypt, 40,000 cubic meter out of 160,000 cubic meter per day. We are using one of the difficult seawater, which is coming from near the delta, where there is a mixture between the Nile River and the seawater, where there is a lot of mud. There is a lot of the TSS is very high, so we are treating, as I think technical guys attending the webinar, they understand what type of water I'm talking about. So we are using a DAF system followed by a media filter and RO. The capacity is 40,000. We are also responsible for operation and maintenance of the plants from 2023, and the plant is running efficiently and producing the required water and within the quality for the last 2 years.
So those are the case studies we wanted to go through. As you can see, Fluence as an organization has done projects both big and small, very complex projects, as Wissam just mentioned with the new Mansoura, dealing with a very challenging water supply, reuse project, and a whole host of others. So one thing to keep in mind as you're looking to partner with a water treatment provider, these items, I put this slide up, these are common requests that Wissam and I receive all the time, whether it's treatment recommendations, CapEx, OpEx, mass balances, a wide variety of requests. These are things that we help our customers with all the time and would like to help you with as well. So just keep this in mind, please. We'd love the opportunity to work with you as we are a global company.
The important thing is that give us your water analysis for the raw water and what is the product water you need, and we can provide you with the solution, the economical solution that fits your requirement.
So thank you for attending today's webinar. I know we have a number of questions. The QR code that's on the screen here will bring you to a link to just one of our website sections. This one in particular has brochures, case studies in more in depth on the projects that Wissam and I covered. There's no login, there's no account set up. It's just a straight folder view. So please look to that as well. It's the same that is on the opening slide of the presentation. So with that, thank you very much. Jessica, do we have any questions available?
Yeah, feel free, excuse me, feel free to add your questions to the chat and we can kind of work through them as they come in. Okay, we have a question here. What about management of the reject streams? Can you share any innovative ways of managing RO, brine, etc.?
There is different case studies and there is different solutions for the brine, which we personally I have gone through. There is evaporation pond. It will take a lot of area, which is most probably not available. While another solution is to dilute it with the feed water or raw water, we can say. Plus, you can dump it in the sea with a perforated pipe, which can be diluted along. This is some of the solutions for, I'm talking about seawater RO or seawater reject RO. But for other, there is a lot of restrictions coming for also brackish water RO that we cannot. I'm talking about our region here in the Gulf, that there is some restrictions we cannot, because the water is going to the sewer system. There is a requirement to reduce it to match the sewage to the sewage treatment salinity, which is around 2,000 2,500, which is also a very difficult situation. There is new technologies under study and there is under piloting, but still we don't have from my experience, we don't have the right solution other than dilution with the feed.
Sure.
I leave it for you, Jared.
Yeah, we see a couple we have increasing restrictions, certainly at least in the US and Canada, on RO reject or RO brine management. There's some, I'd say, minor, maybe more simple ways to manage that, and that's reuse. As Wissam mentioned, with our NIROBOX systems, we use RO reject to actually backwash our ultrafiltration system. So while we can't dispose of that water, we can certainly reduce the amount of fresh water. So there's some ability to reuse that. Irrigation is becoming more common in the US as well. If it's strictly a volume restriction, we can use additional technology like RO, another step of RO to concentrate the brine as much as we can. And we can also use some more special technologies called EDR and a few others to really concentrate that volume down to as low as possible. But yes, it's a major consideration with RO systems, but also any other water treatment system or technology too, is what do you do with the residuals or the waste that's generated by it?
Then there is also some piloting there. If you remember, there is the hollow fiber RO membranes. They are using these such membranes as a brine concentrator for the reject. And piloting, I have been involved in one of the piloting for such system, and it is a proved technology. But again, we are talking about the how much you can sacrifice the power consumption, because the power consumption for such brine concentrator is a little bit high, and some people will call for what we call it membrane crystal, or we call it crystallization. But crystallization is very expensive, and it did not reach to an economical that for big projects or a big capacity plant that can handle, unless you have a source of heat, which I believe not a power plant can give you this source of heat, because if they give us a source of heat, then it means he is losing efficiency on his turbine.
Yeah, but I've been part of a few projects with some, and you're right. If we wrote down every water treatment technology on a list, and always at the very bottom was crystallizer, because it was so expensive to purchase and so expensive to operate that we did everything else before we reached that level. Good question.
I've got another question here. Does Fluence have dealers or usually sell direct to the customer, and where is the manufacturing done?
Sure. So manufacturing is global. We can manufacture in a wide variety of countries depending on the project need, the technology, the timeline. So no issue there. As far as sales path, it varies by the region and by the market. So by all means, though, feel free to contact us directly. First through the website link, email address, Wissam Murad directly, and we can find out in very short order the path of sales for your specific need.
I think Dr. Riyad, he has a question. He raised his hand. I don't know if we can allow such Jessica.
Yeah, let me see if I can. Here we go. I can allow the mic. All right, you just have to unmute yourself and then you can speak.
You are still muted, Dr. Riyad.
Maybe an accidental hand raise. Who knows?
Maybe. Okay.
That happens sometimes. Does anybody else have any questions for the presenters? I don't see anything else coming through, which means you guys must have been extremely thorough. And so I think thank you for your time and for the presentation today.
You can contact us through our info at fluencecorp.com, and our marketing team will divert the email or the question to us, to me or to Jared, so that we can answer you or support you in any solution that you require.
Thank you all for attending.
Yeah, thank you so much.
Thank you. Thank you a lot. Thank you.